The key to finding the volumes of these revolved regions, or the volumes of these solids of revolution, is understanding we are taking an infinite sum of volumes of skinny cylinders. Volume formula of a skinny cylinder is pi r squared h. Here's a skinny cylinder here. Here's a skinny cylinder here. By drawing reflections of regions and an example of a skinny cylinder that you would be summing up the volumes for, you can see this cylinder has a very skinny x distance. It's got a long y, but a skinny x. That is telling me the height of this cylinder is dx. So the height can either be dx. If I have a horizontal cylinder, it's got a long left and right. It's got a very skinny up and down. So that is showing me dy. So height could be dy. You could also base that off of rotating around an x-axis, spinning things vertically. You'd end up using dx and x's. Rotating things horizontally around a y-axis, you need dy's and y's. So that's the first thing, is to understand dx or dy. If it's dx, you need x's, from an x to an x for your boundaries, from a y to a y if you're using dy. So that's the first thing where you have to focus in on, x's or y's. The second thing we focus in on is the radius and the type of solid that we have. This is just a solid. There's no hole here. So I would just focus in on the radius. It's a top minus a bottom. If you want to draw a bunch, just to kind of just make sure you see what we're talking about, top minus bottom, top minus bottom. However, the bottom is just 0, so the radius is just this f of x. Over here, this would be a right minus a left radius. Right minus left, right minus left. But the left is always just 0, so it's just going to be the right, but it's an x equals g of y situation. Again, I need y's with dy, x's with dx. When we rotate a region that creates a solid that is not solid, that has a hole, well, then we need to take the volume of an entire object and then subtract the volume of the hole. The key is to sketch the reflection and then sketch representative cylinders that you would be finding the sum of, the volume of the sum of, so that you would get the volume of the object and then you'd get the volume of the hole. If you need to draw a bunch of them, do so. That way you see, okay, the volume of my object is coming from the red. The radius is a top minus bottom. It's a very skinny x, dx. That means I need an x distance to an x distance, an x coordinate to an x coordinate. Top minus bottom for my radius would be g of x minus 0. I don't need the minus 0, so I just have g of x. I do the same thing with the blue ones. Here are all the cylinders that I'm adding up. The radiuses are always the top minus the bottom, but in this case, it's h of x minus 0. It is when we are revolving around a line other than the x-axis or the y-axis that we really need to be careful. We really need to make sure we understand what the reflection looks like, and then we draw our representative cylinders. One that goes to the outside, one that goes into the inside. Draw a couple to help you out. What's skinny about them? The x. So I'm starting from this x coordinate, eventually ending up to this x coordinate. Now, what is the radius? Well, I'm not going to be using my reflection because I don't know the equation of my reflection up here, but I do know the equation here. This is p of x and this is r of x. This is when we need to adjust our radius and we need to use top minus bottom, or a right minus left, depending on the situation. This would be 5 minus p of x. Those red cylinders would give me my entire object. Notice p of x is on the bottom. It doesn't matter about bottom or top in this situation. It's about outsides and insides. Then the blue cylinder, this radius of this blue cylinder would be 5 minus r of x. Now, I have 5 minus p of x here. I have 5 minus r of x here, but I also threw down r minus 5 and p minus 5. Why could I do bottom minus top and still be okay? Because I'm squaring the radius. So it doesn't matter if you get a negative radius or a positive radius because you're squaring it. So I would prefer you guys, because it will make more sense to you, to just embrace top minus bottom and to get the positive radius squared. However, you can use this if you'd like to. And again, you could always simplify this integral so you don't have to type in 2 integrals into your calculator. Just one integral with 1 pi of an outside radius squared minus an inside radius squared times either dx or dy. This all being in parentheses. Okay? Here we go. We have a region. I'd like you to spin around the x-axis and the y-axis. Step 1. Sketch the region down. This is 4 minus x squared. X equals 0. Y equals 0. Start with that. Step 2, draw your representative cylinders. Either a cylinder, if we have a hole where we need a cylinder going to the outside and a cylinder going to the inside, or if you realize we have a solid object, we just need cylinders going to the outside. Understand what's skinny about that cylinder. Is it a skinny x distance or is it a skinny y distance? That is telling you dx or dy. If it's dx, you need your x boundaries. If it's dy, you need your y boundaries. Then discover the radius. It's the top minus bottom. In this case, the bottom is just going to be 0. Once you get your integral written down, plug it into your calculator. You should get 53.6165. The cylinder goes all the way to the bottom. But the radius is just that. Okay? Sketch the region. Sketch the reflection. We're revolving around the x-axis. Draw a cylinder. Mark off whether it is a skinny x or a skinny y. That's telling you dx or dy. That's leading you to understand your x's, or if you're y's. What is skinny about this cylinder? The up and down or the left and the right? No, up and down is long. The left and the right is skinny. Right? This is skinny. So the x is skinny. So dx. Okay, reflect this around the x-axis. What is it going to look like? Yeah, be like this. Draw a cylinder. You draw a bunch of cylinders. So draw a bunch of cylinders. Yeah? Now, where are these cylinders starting?
From 0.
And where are they going to? X's, right? So that means X's, I need dx. What's the radius of the cylinder? It's the top minus the bottom. The top is determined by this curve. The bottom is just 0. Don't forget to square it. It's pi r squared. Type that into your calculator. Everybody should be typing your integrals into your calculator to make sure you know you're doing this correctly. You should feel pretty good when you're doing these problems and you get the same decimal that I get. Pi r squared h. So don't forget to, first of all, get a pi in front of there. Sorry. And then to square this, you'll have to put it in parentheses and then square it. Okay? It's no longer just f of x dx. That's area. That's height times width. It is now pi r squared h. Don't forget the pi.
Did you get the 2 by setting the 4 minus x squared equals to 0?
Yes. Now, when I revolve it around the y-axis, here's the y-axis. I actually get reflected this way. Okay? Extremely important to draw the reflection and to visualize your cylinders that are being revolved. Throw a bunch down if you want to. It might help you understand your boundaries. I'm going from 0 to 2. My radius is a y distance. I'm also thinking 0 to 2. Those are x's. I'm looking at this line. Some of us are not understanding this, but if I look at this cylinder, it's a long y. It's a long up and down. It's a very skinny x. That is telling me dx. So 0 to 2, the radius is a top minus bottom, but the top minus the bottom is always going to be 4 minus x squared minus 0. 4 minus x squared minus 0. So that's why I get integral from 0 to 2 of pi 4 minus x squared squared, that's pi r squared, h, in this case is dx. Okay? Now, reflecting over the y-axis, my cylinders now need to be horizontal. Okay? Change up your integrals. Make sure you understand what's going on. We need 25.1327. What's skinny? The y is skinny. What am I going to be summing them up from? From 0 to 4. If I have dy from 0 to 4, I need y's. Don't forget to square things. Oh, you got negative. Oh, where are we right here? Let's solve this for x again. You have to. You have to, if you subtract the 4, you'd have to take the opposite of it before you square root it.
Yes, I could have just done 4 minus y.
Yes, x squared equals 4 minus y. So the root of 4 minus y. If you flip this to 4 minus y, that's y. Okay, so you just didn't solve for x correctly. Okay, you got the first one. Now let's make sure we get the second one. Okay, so then the root and the square will cancel out. That square's gone. If you squared the square root, then you squared the square root. The square's gone, the square root's gone.
Right, okay.
So did you type in the square again?
Yes.
So that's why. Okay. So we're starting to get it here. I have x equals y's, right minus the left. But to solve this, I can add x squared, subtract y, square root it. You should get x equals root 4 minus y, or negative y plus 4. If you throw that in here, you're good. If you square the square root, they both go away. You're still good. 4 minus y, not y minus 4. That's why you got the opposite. 4 minus y. Okay. Next, please revolve this region around the y-axis. You should get 60.318. This is y equals x cubed, x equals 0, and y equals 8. I'm telling you that they intersected 2 and 8, but you should be able to find that by yourself. Thank you. Draw your reflection. Draw your cylinders. Understand what's skinny, or understand the summing of them, whether you're using x's or y's. You can set up your boundaries in your integral, pi, stuff, squared, dx or dy. There you go. Plug that in your calculator. You should get 60.318. Everybody should be plugging the integrals into their calculator to get the correct one. Okay. What is this radius? Right there. So right minus the left. What's the right?
2.
I mean, it's not always 2 because it's changing.
Mm-hmm.
So what is the radius based on? What's the right based on?
So 2 minus y.
No, I mean, what's this curve here? Where'd that curve come from?
The x3.
Yeah, it's the x cubed. Okay? The x cubed. Now, you got dy. You're good there. 0 to 8. You're good there. That's perfect. Good understanding of that. So, if my radius is coming from this x cubed, I need to change it into an x equals equation. But that's it, though. It's a right minus left. The right is the x cubed, or x equals the cubed root of y. The left is 0. That's it. You got it. We're good? We're good? We're good? Is everybody good? Everybody fine? Good? Yeah? Don't square square. Don't square square. If you're cubed root of y squared, that's r squared. If you're doing r to the 4th, don't do r to the 4th. Good. It should just be an integral from 0 to 8 of a pi. My radius is consistently going to the curve. That curve is giving me my radius. The curve would be an x equals cubed root of y, or y to the 1/3 squared. Okay, great. Now we're going to change it up. We're going to add a level of difficulty. I'd like you to revolve this region around the x-axis. You need to draw your reflection and then notice how things have changed. Now, it's not the entire region. It's just this part in the first quadrant revolved. So, start. Step 1, draw your reflection correctly, so that it gives you a sense of what the region looks like, the object looks like. We get this. Does everybody have that type of shape? You know, it's not beautiful. You see that?
Oh yeah, I thought we were doing the one that we just made over there.
No. This one, just the first one. Okay. Now, what do we notice about this object that's different from the last 3 things that we did? There's a hole. There's a hole. Now we need 2 sets of cylinders. I'm going to draw red cylinders that will give me the volume of the entire object. I can see what the radius is of all of those cylinders. And then I'm going to draw blue cylinders that would give me the volume of the whole. Take the volume of all the red cylinders, I'll call it the volume of my object, subtract the volume of the blue cylinders, the volume of the whole, and you will get the volume of the object you're looking for. Start with the reflection, and then physically, I'm not doing this for my health, I'm doing this so that I can understand what I'm using. I got my red cylinders and my blue cylinders. They're very skinny X's. I can see the radius of my red cylinders actually stays consistent. I can see the radius of my blue cylinders is changing. The radius of my blue cylinders is based off of the curve. The radius of my red cylinders is just based off of a line. If you are not drawing the cylinders yourself, you're not going to have a good time. I'm drawing it for you. I'm hooking you up. I don't want you to rely on this. You need to be able to draw these cylinders. It will help you tremendously. It's still good to think top minus bottom, though. So look at the cylinders here. What is the radius of all these cylinders? What is it going from and to? What's the top minus the bottom? Is it? Here's the bottom of my radius here. Here's the top of my radius. Here's the bottom of my radius right here. Here's the top of my radius. Is it going to the curve? Here's all of these red cylinders goes to the outside. Here's the top. Here's the bottom. Here's the top. Here's the bottom. 8 minus 0. Now, here are my blue cylinders. These would be giving us the volume of the whole. All of these radiuses are now changing. I have a curve as the top and the bottom again being 0. So what would be the radius of my blue cylinders? Just x cubed minus 0. That's it. You must draw cylinders on your paper. If you're not, it's not going to be great for you. You're not going to understand what's going on. Drawing, this is why I told you to draw representative rectangles when we were doing area. All of you didn't listen to me. But now you must, okay? Because I must understand that the radius of the red cylinder is just 8 minus 0, or 8. The radius of my blue cylinder is based off of the curve. It's changing. It's the x cubed minus 0. Pi r squared h, 344.677. Okay? If we didn't get that, you'll do it better on the next one, because we are taking this region, y equals x cubed and y equals 4x, and we're revolving it around the x-axis and the y-axis, creating two shapes that have holes. So you're going to have to do volume of the object minus volume of the hole for both directions. Whereas the last region, one way had a solid, one way had a hole. I'm telling you that the intersection is 2,8. You are expected to know how to find that intersection. You will be given your calculator today, so you can just be lazy and just graph and second calc intersect. But you should be able to know that by solving, x cubed and 4x will intersect at 2,8. Draw your region, draw its reflection. Draw your cylinders. Some cylinders going to the outside, some cylinders going to the inside. Cylinders going to the outside is going to go all the way from the top, the outside, all the way to the bottom. The cylinders for the inside will be like the inner parts. So you get 76.595. Please help your neighbors if you are not getting it and you're not understanding. I love this lesson. I think this lesson really helps everybody understand what the integral is doing, where it comes from. So you have things going left and right.
I was just show the area in the hole, but I know.
Okay.
Up.
You know we're going up.
Yeah.
I'm going to do this for you, and I'd like you to do this in the future. And then, okay, I got outer cylinders and inner cylinders.
Mm-hmm.
I'm going to then mark off the radius of all my outer cylinders. What is the radius of all of my outer cylinders? Top minus
4x
bottom,
minus
the
0.
4x minus 0.
Mm-hmm.
Good. What's the radius of all my inner cylinders?
So that'd be just x cubed minus 0.
You got it. Starting at 0, going to 2, you got it. What's skinny about the cylinder? The x, it's dx. So you got it. You can't forget the r squared, pi r squared. But you got it, right? Boom, outside, yep. Inside, good. Just type it into your calculator, that way we get it. Okay, revolve this around the y-axis as well. Inner cylinders. Let's look at our inner cylinders. You got the outer cylinders. 4x, 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 minus 0, minus 0, minus 0. Okay. Inner cylinders. Here is the radius. Here's the radius. Here's the radius.
X cubed minus just x cubed.
Yep, minus 0.
Oh, okay.
Okay, you're doing the y-axis here. I mean, which one are you doing? It looks like you're reflecting over the y-axis. You need to be drawing two sets of cylinders. One going to the outside. All of these red cylinders would give me the volume of the entire object. We will then subtract all of these blue cylinders. That would give me the volume of my hole. What is the radius of the red cylinders? It's going from here to here. And you can always calculate a horizontal distance by doing a right minus a left. What is the right minus left always going to be? What's always on the right of those red cylinders?
2.
No, it's changing. This isn't 2 here. This radius is not 2 right here.
Would it be x cubed?
Yeah, it's the x cubed. But it's an x distance. It's a skinny y, so it's got to be x equals cubed root of y.
Gotcha. Okay.
Because you need to solve for x. Yep. Okay. Now the blue cylinders. What's the radius of the blue cylinders?
It'd be x equals y over 4.
Yes. Minus 0.
Minus 0. Yeah, because we're going to that.
Because you're going to the y-axis. You got it? Yep.
He's correct. He said right minus left. So it's the right.
No. You're drawing a vertical thing. Here's the radius. Top minus the bottom. Top minus bottom.
This is
Top
right
minus
minus
bottom.
left. The y-axis.
Right minus left distance. Right minus left distance. Right minus left.
Okay.
Okay, so what's the top minus the bottom here?
So the 4x minus 0.
Okay, and then for the inside, draw a couple inner cylinders. Okay, what's the top and the bottom for the inner?
So x3 minus 0.
Yep. So this should just be 4x squared minus 0, and this should be x cubed minus 0. Okay, make sure you're drawing two sets of cylinders. Cylinders going to the outside. That's going here. The radius is going here. Then cylinders to the inside. That radius is going here. Make sure you're squaring. Okay. Notice the outside and the inside changed. For this one, the outside was the 4x that determined the radius, and the inside ended up being the x cubed that determined the radius, or x cubed minus 0. For this one, the outside ended up being the x equals cubed root of y distance, and the inside ended up being the x equals y over 4 distance minus 0. Okay, right minus left or top minus bottom. Now let's add another layer of difficulty, and these were our answers. Volume of the object minus the volume of the hole. Okay? Pi r squared h, pi r squared h. Any questions about these? Now, keeping in mind, to find a vertical distance, you can do a top minus a bottom. Keep finding a horizontal distance, you do a right minus a left, a right minus left. We are going to start revolving regions around lines other than the x-axis or the y-axis. I'm going to revolve this region around x equals -1 and x equals 3. Especially for these, you need to draw the reflection, and you need to draw your cylinders, your rectangles being spun, and you need to identify the radius that you're trying to calculate. And especially for these, right minus left or top minus bottom will help you, depending on the situation. Draw the reflection, draw your cylinders. If you're still not drawing your cylinders, you're not helping yourself out. If you think x equals -1 is a horizontal line, start over. X equals -1 is a vertical line. Some of us will make that mistake. And that's okay. Let's just not make that mistake again. There's a sketch of my reflection. It's not great, but whatever. And now, so vitally important is the understanding of the cylinders going to the outside. Here are my red cylinders going to the outside. You can see they have to be horizontal, which means it's got a very skinny y, which means I need an x equals y distance, or I need a x equals y functions, and I need x distances. And now I have my cylinders in blue. Mark off the radius you're trying to calculate. From here to here, from here to here, from here to here. Right minus left would be that distance. For my blue cylinders, I'm going from here to here as my radius. Here to here. Here to here. Right minus left. What is skinny about these? Up and down or left and right? Up and down is skinny. Left and right is long. Since up and down is skinny, dy should be used and y's should be used. So x equals y equation is what we need. That's left minus right. It'll work. But right minus left will give you the positive radius. You're doing left minus right, it's going to work, but right minus left would be the correct positive radius. It works because we're squaring. Okay? You can use my cylinders up there. The red cylinders, what's the radius? Yep. Good. Oh, you have it down. You got it. Very good. Yeah, that looks great. Plug that in your calculator. But there is one thing that's wrong. There's one thing that's wrong. Almost correct. You see these cylinders? Where are they starting? Down here, up here, over there? Right here? We're starting them down here. Yeah? And then we're adding them up to when? So change your boundaries, and you got it perfectly. It's going to be right. 51.94. You plug it in your calculator, you should get 51.94. Spin this region around x equals 3. You're not adjusting the radius. You're not doing right minus left. You're just doing right.
You need a minus.
But now it's a left. There's a left right here. This distance right minus left, right? You were always doing minus 0 as you're going along. And that's good to do it because now we know we have to do minus negative 1. We're good?
Second one?
Yep.
Yeah, I'm actually good.
Good.
Second one, you're doing it, are you still doing it vertically? Or are you doing it?
Well, let's see. X equals 3.
Okay, so you're doing it.
X equals 3. Oops. Oops. For our first one, my red radius should be cubed root of y minus negative 1. My blue radius should be y over 4 minus negative 1. I'm going from 0 to 8. My right minus my left changes. My outside and my inside changes now that I'm reflecting this around this x equals 3. By drawing my cylinders, I can see visually the outside radiuses, the red radiuses, and the blue radiuses. The red radiuses are now 3 minus y over 4. Here's x equals 3. Here is x equals y over 4. X equals 3, y over 4. 3, y over 4. 3, y over 4. 3, y over 4. My blue radiuses are now 3 minus the cubed root of x, cubed root of y. 3 x cubed, or cubed root of y. 3 cubed root of y. 3 cubed root of y. You have to be able to understand that, and that's a right minus left. The right now ends up being the number. The left ends up being the function. Yes? You could have done the function minus the number, however, because you're squaring it. I'd like us to keep this in mind, though. I think it'll help us in the future, but you could have done y over 4 minus 3. You could have done y to the 1/3 minus 3. Okay? We got to move on, because we're going to now reflect things over y-axes. And let's just do one of them. Because if we are drawing things correctly, it should not matter which direction we are throwing things in. Let's revolve this same region around. Which one do you want to do? Y equals 10 or y equals -2? Let's do 10. Do this one. Y equals is a horizontal line. If you draw your reflection, and draw your cylinders, you should be able to get this. Everybody, let's get 174.73 in our calculators and feel good about ourselves. You got it. Now, 0 to 2. Are those x values or y values?
X.
I need x's.
Um,
X's, x's. X's, x's. Y's, y's. Yep. I would say, though, just to be careful, though, you're going to get the same answer when you plug it in. And you need to type it into your calculator. That way you make sure you get the same answer. That for my outside, there it is right there. I would say it's 10 minus x cubed. See how it's that top? Like, I don't know what this reflections equation is. So that's why I'm going to use this one, which I know. 10 minus x cubed. And then for the inside,
That'd be 10 minus 4.
got it? Okay, make sure you type it into your calculator, though, because sometimes typing into our calculator is tricky.
That's how you type that in.
Where's pi?
Oh, yeah.
Now, you're opposite of the correct radius. As long as you understand that, it's okay. Okay, I see a lot of us. I see a lot of us writing the outer radiuses as opposites of what they actually are, which ends up working out because we're squaring the radius. But I'm not going to use this guy. It works out if you say it's x cubed minus 10, but for this radius, I'm going to use that as the top and the function that I know, because I actually don't know what this function is up here. It's some sort of reflection of x cubed, but I don't know the equation. I'm going to say it's 10 minus x cubed, 10 minus x cubed, 10 minus x cubed. The radius is 10 minus x cubed. If you have x cubed minus 10, though, fine, because you're squaring it. For the blue radii, which is the inside, 10 minus 4x, 10 minus 4x, 10 minus 4x, 10 minus 4x. If you have 4x minus 10, it'll still work. You'll get the same answer. I just want to make sure we understand, like, oh, that's the radius. That's how I can calculate it. It's the top minus the bottom. Got it? All right. Anybody need help entering things into their calculator? Or anything else? Okay. I'm giving you a new region. Y equals e to the x and y equals 4x plus 1. Do not delete this region from your calculator. I'll explain in a second. The region looks like this. The first thing I'm telling you is this first intersection is at 0, 1, not at 0, 0. So that's new. You need to find this intersection. Let's revolve this region around two lines, x equals 5 and y equals 12. Yeah. Yeah, you got this extra square here. That's one thing.
Okay.
You have an extra dx, so you're taking like two integrals. So well, if I get rid of that other integral, it probably took you forever for your calculator to calculate this. Am I right?
Yeah.
Yeah, because you have a lot of stuff going on. Just start over and type it in again. You had integrals within integrals and stuff like that. Sometimes when you copy a previous thing from your calculator, it will copy it into another integral, and all of a sudden things get crazy. So it might be best to just type in the integrals separately. You will need to hold on to that intersection, that other intersection, and understand the intersection's x-coordinate, maybe label it on the x-axis and the y-coordinate. Where am I reflecting it? X equals 5. Where's x equals 5? X equals 1, 2, 3, 4, 5. X equals 5. Yeah, looks perfect. Looks great. Okay? So I'm looking at this length, this length, this length. Right? What are those lengths?
This would be 4x plus 1.
What is, no. This length, this length, this length. From here to here, from here to here, from here to here.
Is it 4x plus 1 minus 5?
It'd be 5 minus the 4x plus 1. Right? But that's fine if you do 4x plus 1 minus 5. Now, am I going up to sum up all these cylinders or left and right?
Left to right.
I'm going up.
Oh, up?
Yep. Horizontal. What's skinny about this line? It's got a long width.
Okay.
It's got a very skinny height. So that's telling me dy. Y's. So it's got to be y starts at 1, goes here.
Okay.
Which means it's not going to be 5 minus 4x plus 1. It's going to be 5 minus x equals whatever that equation is. Okay? Now for your insides, right minus left, right minus left, right minus left. 5 minus that e to the x, but you have to solve that for x equals y.
For the y work, but do we need to include all the stuff in there?
Yes.
Okay.
You're telling me that the x is, you're telling me?
Yeah, I messed up.
Okay,
That's him.
good. Now, you're looking at the red ones, right?
Mm-hmm.
This is not e to the x. This is the straight line. This is 4x plus 1. So the way you drew it, you're right, but e to the x is the curve. 4x plus 1 is the straight line.
Oh, okay.
Okay, just solve this for x. Solve that for x. You put it right there. You put it right there.
The boundaries for the 2.5.
So you actually have to find the actual intersection. You don't know what that intersection is, but you need to find that y coordinate using your calculator. All the work you're doing, don't clear it. Hold on to it. Got it? Okay, do the other one, the y equals 12.
No,
Yep.
I thought
Yeah, because this number is not exact enough. This intersection is not just at 10. You can't assume it's just at 10. The intersection ends up being at 10.346652.
Okay.
That number needs to be in your interval. Please revolve this around y equals 12 as well. It's not going from 1 to 10. You need to find the exact intersection of those two graphs. It's not 10. It's 10 point something, something, something. You need to find that.
Oh, wait, no.
Good. 5 minus that. 5 minus that. Good.
I should.
Right. Yep. Nope.
No, it isn't.
Close. So close. So close. So close. So close. Am I starting at 0?
Starting at 1. Oh my god.
It was 91.94. Second one is 171.676. Okay, we have to take the quiz now, so that you have enough time. What was the debate over there? Yeah. Do not delete anything in your calculator. Don't delete anything, especially the problem we just did. Please start on problems 5, 6, 7, 8, which is revolving the region y equals e to the x and y equals 4x plus 1 around different things. That's why I told you not to delete anything in your calculator. You should already have integrals plugged in that you can just like reuse with all of those intersections already plugged into them. You just got to be able to understand which ones to use in which situations. And we should understand we're going from either 1 to 10 point that decimal or 0 to that decimal, x decimal.